let's look at one of the properties of a function, increasing. If you pick an x1 here greater than an x2, let's say over here, then does f of x1 have a value greater than f of x2? Yes. So if an x value, x1, is greater than an x2, is f of x1 greater than f of x2? Yes. In other words, is it increasing? That means it's going from lower left to upper right. It's an increasing function. Let's look at decreasing. That would be for x1 less than x2. Do we have f of x1 greater than f of x2? So pick an x1 to the left of x2. Then is f of x1 greater than f of x2? Yes. So it's going from upper left to lower right. A constant for x1 less than x2, we have f of x1 equals f of x2. That is, where you put in a particular x value, you're getting the same y value. Constant function. So for any x1, for example, here, and another x2 over here, you're getting the same f of x1 and f of x2 values. So let's look at the behavior of this function. So if we look to the left of -3, it's increasing. So we would define this function in 3 different ways. It would be increasing in the interval between -infinity and -3. It's constant between -3 and 3 in this interval in here. And then it's decreasing from 3 to infinity. So we can define this function in different portions of it and talk about its behavior. Where is it increasing? Where is it constant? Where is it decreasing? So it may not be that the entire function is increasing, decreasing, or constant. It may have different portions that you need to look at. So let's take a look at this function. It is a function. It passes the vertical line test. And I want to look at where there's a relative maximum and a relative minimum. So there's a relative maximum at this point. It's relative to that portion of the graph. And there's a relative maximum here. There's a relative minimum at this point and at this point down here. So it is not strictly where is the maximum point. It's relative to that particular portion. So there, in this problem, there are 2 relative maximums and 2 relative minimums. Let's take odd and even functions, just properties of functions. If I substitute -x into the equation, I should get exactly the same equation back. So f of -x is the same as f of x. For example, in this problem, if I start out with f of x equals x squared, and I substitute in -x in place of x squared, in place of x, and then square it, I have the exact same function again. And this means that this is an even function. Something like this, because if I put in 2, I get 4. If I put in -2, I also get 4. This is also symmetric. with respect to the y-axis. So if you were to look at this graphically, that's a property of an even function, that it is symmetric with respect to the y-axis. If I go over 2 to the right for x, I'd go up 4. If I go to the left, -2 and up 4, I'm going to get a point on the graph. Property of an odd function. If I start out with f of x and I substitute -x in place of x, then I get negative f of x. That means all of the values in the fraction, in the function, are changed. So for example, if I have f of x equals x cubed and I substitute in -x, that's negative x quantity cubed. Negative x times negative x times negative x is negative x cubed. That is the exact opposite sign of what we had for the function. It was positive x cubed, it's now negative x cubed. And we might have a graph that looks like this. The property of odd is that it is symmetric with respect to the origin. Now, what does that mean? It means that if I go through the origin and I have, for example, a point -2, -3, I now would have a point on the graph that would be going over +2 and up 3. So through the origin, we'd have symmetry. Point -2, -3 is on the graph. A point +2, +3 is also. Looking at each of these 3 examples. Is the first one odd, even, or neither? It's odd because it's symmetric with respect to the origin. How about the second example? It's even because it's symmetric with respect to the y-axis. And the third one, it's not even a function because at 0 we have 2 y values and therefore it's not even a function, but it's neither. Okay, let's take the first example. I have f of x is equal to x over x to the 5th minus 3x cubed. If I want to know if it's odd or even, then take and substitute in f of -x. Now in the numerator, that means we get -x. A negative x to the 5th power gives you -x to the 5th. A negative x to the 3rd power is -x to the 3rd times -3 is a positive 3x to the 3rd. Now, a negative divided by a negative in a fraction is the same as a positive. So if I factor a negative out of the numerator, and I factor a negative out of the denominator, here, so I had a numerator and denominator have a negative factored out, and negative divided by negative is a positive. So actually what we're getting here is exactly like we started with, because a negative divided by negative is a positive. Since this looks exactly like the original, then this is an even function. So you have to be careful. Let's take a look at another example. Substituting in a -x. -x squared is x squared. -2 times a -x. Take care of that in a minute. X to the 4th, a -x taken to the 4th power is still going to be x to the 4th. So a negative times a negative, we're getting x squared plus 2x over 5x to the fourth plus 7. This is not exactly the opposite of what we started with, because we had x squared minus 2x, we now have x squared plus 2x. Both of those quantities in the numerator have to be different, and the denominator is exactly the same. This is neither. Okay, if we substitute in negative x times negative x times negative x is negative x cubed, and negative x squared is x squared plus 1. This is changing just the numerator, but not the denominator. If we change both, we actually have an even function. So changing just the numerator or just the denominator completely with the signs makes an odd function. So what is the domain for this? Yes, negative infinity to infinity, side to side, left to right. What is the range for this? The up and down, the y value. What's the minimum y value to the maximum y value?
Negative infinity to infinity.
Right, because I have the arrows. Now if I drop the arrows off, it would not, but this is going to continue. So again, we have from negative infinity to infinity. Had I taken the arrows off, it would have gone between a negative 3 and positive 3. The x-intercepts. What are the x-intercepts for this graph?
-4, and I have a question. That's why I was being.
Uh-huh.
When it goes through the origin, do you consider that like an intercept?
It is an intercept. Where does it cross the x-axis?
Yeah, so it would be 0 and 4.
And 4, yes. -4, 0, and 4. What are the y-intercepts? Where does it cross the y-axis?
0.
At 0. Where is it increasing? Yes. From -2 to 3. Where is it decreasing? Okay, decreasing, it's coming down on the left from negative infinity to -2, or it's decreasing again from a positive 2 to infinity. So it's decreasing coming down here, it's decreasing down here, and it's increasing in here. Yes?
Wouldn't it be decreasing from 3 to infinity?
It's a minimum at -2, -3. And where is there a relative maximum? At 2, that's actually supposed to be like at 3 here. At 2, 3, the graph is not real clear. Do we have an odd, an even function, or neither? Is it symmetric with respect to the y-axis, which is even, symmetric with respect to the origin, which is odd, or there is no symmetry with respect to either? What do we have here?
Neither.
No, we have that it's symmetric with respect to the origin. It's odd.
But there's no, like there's a 2, 3, but there's no -2.
But we're going through the, oh, yeah, this should have come down further. Yeah, okay, neither. I think I should have drawn the graph a little bit better, but it should have, because this is the point 2, -3, and this is the point 2, +3.